So in algebra, we have a couple of things that we use to kind of help us visualize the relationship between inputs and outputs of something that you may have heard called a function. Okay, so we're talking about this thing called a function, right? And a function is essentially any set of inputs and outputs. Okay, it's a way that you relate inputs and outputs. So for example, you might be given the function y is equal to x plus 2. Okay? And what this is saying is that for any number x or any value x, if you add 2 to that value, you're going to get a y, right? And y is equal to any value of x plus 2. Okay? So you can map that out. And we can actually put this in a table, right, and make this kind of a visual thing, and we can kind of show the relationship between any value of x and any value of y. Why don't we start with a table that looks like this? So we're going to have x, the input, x plus 2, which is the actual function itself, right? This is how we calculate our y, and then we'll put y in this last box here. And let's assume that we had, let's do -1, or well, yeah, let's do -2, actually. Let's do -2, -1, 0, and then we have 1, and then we'll have +2, okay? And we'll use those for our function. So if we plug in x, right, if we plug in x into this expression here, and we have 2 or -2 plus 2, right? We know that if we have -2 plus 2, right, if we add those two together, we're going to get 0. If we plug in -1 and add in 2, we're going to go 1 to get to 0 and then 1 more. So we're going to have a +1. If we do 0 plus 2, that gives us +2. 1 plus 2 gives us 3. And then 2 plus 2 gives us 4. Okay? So we can take our function, our expression here, and then plug in any value of x and get any value of y. Okay? And there's the relationship here. But we can take this one step further. We can actually graph this out and give us a visual representation. We can make this thing a line. And in fact, we're talking about this thing called a linear function. Okay, a linear function. And this is anything that when you graph it, gives it a line, right? There are nonlinear functions and linear functions. We can separate that. But for now, we're just going to stick with any function that if you graph it on a coordinate plane, you get just a single straight line, okay? And again, we can use our inputs and outputs. If you took this away, if you took this middle section away, you actually would notice that there is our coordinates here. You could make those into coordinates with an x and a y. So I'm going to do that so we can see it. We've got x, and then we're going to have y. Because remember, any coordinate is a mixture of a distance left or right, a horizontal distance, and then a vertical distance. And so for point 1, we're going to have point -2 and 0. That's our x and our y. We'll have -1 and 1. 0 and 2, 1 and 3, and then 2 and 4, right? And those were the same numbers that we got over here. And what we're going to do is we're actually going to take these points and we're going to graph them. Okay, let me change my color here for you. And let's say that, let's start at -2. So remember, this is our x, this is our y, right? And we're going to graph this on here. Let's start with x. We're going to go a distance, if this is 0 in the middle, right? We're going to go a distance x left. This is -1. This is -2. So I'm going to start here. And then I'm actually going to go up 0, right? Because this is my 0. This is -2. So my point, the crosshairs right here fall on -2, 0. We also have negative 1, 1. So I'm going to go over negative 1, and then I'm going to go up to positive 1. I have 0, so I'm not going to move anywhere. It's going to just stay here. It's going to stay on the y-axis, and then I'm going to move up 2. And then we have 1, so I'm going to go in the positive direction, because remember, this is a positive side, this is the negative side, and then up is positive. Draw that again, positive, and then this is negative. So I'm going to go to the right once, and then up 3. 1, 2, 3. And then we go over 2 and up 4. And we could continue this line, right? We could continue this from here all the way to infinity, right? We can make any value of x, but we're just going to stick with 5 values, okay? And we can take that, right, and we can actually just draw a line to represent where this is going. So, and you can notice kind of how this is hopping, right? You can see that this just goes up by 1 every single time, because our x value is going up by 1. So our solution, right, y was our solution for this x plus 2, is also going to go up by 1. So this is a 1-to-1 relationship. So we can actually extend this. I'm just going to take this guy and extend it out here, right? And then we would make a line that looks like this, okay? And so you've got this line of y is equal to x plus 2, okay? And again, this is a linear function because we have a line, there's no curves, it's straight, it follows the same pattern all the way through, it doesn't change, and it continues in a straight line, okay? And you can do this with any function, right? You can do this with another function. Let's say we had, let me change colors here. Let's say we had y, let's say our second function was y, oh, that's a bad color. Let's do this. Y is equal to, let's say, x minus 1, right? And we can again draw our table. We're going to have an x value. It's going to be separated. Our actual expression here is x minus 1. And then we have y. And we'll draw our table like that. And we can use the same values here. Let's do negative 2, negative 1, 0, and then 1 and 2. Right? And then we can also, we'll just plug those in, right? Well, negative 2 goes in for x, so it's negative 2 minus 1, right? And so we have negative 2 minus another 1 would give us negative 3. Negative 1 minus 1, right, gives us negative 1 minus 1 gives us negative 2. 0 minus 1 gives us 1, or excuse me, negative 1. 1 minus 1 gives us 0. And then 2 minus 1 would give us just 1. Okay? And so again, you are going to get this, function here, right? This is a linear function, and we can graph it using this same graph too. If we wanted to, we can kind of see how these are different, right? So instead of x plus 2, we're going to have x minus 1. Okay, and I'll graph it in this blue color for us here. And again, what you're going to notice is that we're going to have a straight line. So we'll start with negative 2 and negative 3, because these are our two coordinates, right? We're going to use negative 2 and negative 3, right? And so we'll have negative 2 over here and then down to negative 3. That goes right there. And then we have negative 1 and negative 2. So 1, 2. Right there. We'll have 0, negative 1. Right there. We'll have 1 and 0. So that stays on the x-axis right there. And then we'll have over 2 and up 1. Okay. And again, we can draw a line between the two of them, or between the first and the last point, right? So you can see that this relationship stays the same. It's a 1-to-1, right? So for every one that the x-axis travels, it's also going to travel one in another direction for the y, right? So if we're going to the left on the x-axis, then we're going to move down on the y-axis 1, and if we go to the right on the x-axis, then we're going to go up. Okay, and you can see that this is the y equals x minus 1 line. Both are linear. They're actually both parallel, right? Because our slope here is actually just 1, right? If you know anything about slope, we can see that they're both 1 because there's a coefficient in front of x. So that's why this is a 1-to-1 relationship. And since they have the same slope, they're parallel lines. They're not going to cross. The only thing that changes, right, is their y-intercept. So in the y-intercept, the y-intercept, okay, which is the place where that line crosses the y-axis, that is determined by your last number here. We have +2 and then -1. So the y-intercept for this first line is over 0 and +2, right? So that +2. And then here we cross the y-axis at -1. So our y-intercept is -1. Okay? And that is how you graph a linear function.